Today we're going to compare two different types of word problems and equations, and the ones that you have been asked to write before and the ones that we're now looking at writing. So let's start by reading this word problem. Ricky bought tickets to a basketball game that cost $10 each, and he had to pay $20 for parking. He spent a total of $70. Write an equation for the number of tickets, X, that he bought. So we are going to start by writing our equations. We know the total, so $70 is what we're going to start with. So 70 is equal to, and now we know what we have for a cost. The cost is $10 each, so that's per ticket, which is X, plus we have the $20 for parking. So we are going to have our $10 for each ticket, so 10X, plus our one-time fee of the $20. So that is our first equation. So now let's compare that to a second type of problem, right? So at this point, I'd like you to pause and look at what's similar and what's different in these two types of problems. So as you notice, the first part, the cost of the tickets and the parking, stays exactly the same in these two types of problems. What's different is in the first problem, we know the total. We know that he has $70 in total. In the second problem, our total is going to be represented by Y because we don't know what the total is. The other thing that's different is what the equation is asking to find. So in the first one, because we know the total of money, we're trying to find out how many tickets he purchased. So when we wrote our equation of 70 is equal to 10X plus 20, we're solving for X to figure out number of tickets. The second problem, our equation, our total is Y, but then all the other information is the same. We know it's $10 per ticket. We know it's a $20 parking charge, so that plus 20. But when we solve for this, we're going to end up solving for the amount of money that is spent. So we have two unknowns here. We don't know the number of tickets, and we don't know the total cost. So what would that look like in a graph? Well, in this graph, y equals 10x plus 20, we are going to start by first graphing our y-intercept. So we start with the charge that we have for parking, which is $20. So at 0, 20, we put a point. And then for every ticket, we're going to spend $10. So if we were to get one, we would have spent $10 plus 20, which is 30. If we got two tickets, it would be $20 plus 20, which is 40, and so on. And as we keep making those points, notice that all of those points create a line, because this particular equation is something called linear. And it's linear, notice the word line in there, because all the points are in a line because there's a constant rate of change. Notice that when we had a proportional relationship, like if we just had y equals 10x, that would have been linear as well, except it went through the origin. So this is a linear relationship because it's a line as it's created with the constant rate of change, but it doesn't have to just be through the origin. So let's look at one last piece. Where would the point be if we were looking at that original equation that we had, which was 70 is equal to 10x plus 20? So again, it would only be 1 point because we would want to go to look at where 70 was. So 70 falls over here. So I would go to 70 and I would see where it crosses my line. It would end up crossing right there. So I would go down and I would see that that would be at 5 tickets. So because I had a total amount in this equation, it's going to be 1 point on this line that I have if I have the open-ended equation that's up here.